My name is Sébastien Deleuze. I'm a Spring Framework committer at Pivotal, and I'm also responsible for the Kotlin support in the various Spring projects. And today we are going to talk about the state of Kotlin support in Spring. I would like to start by talking about why Kotlin, why I choose to work on Kotlin, and why maybe you could be interested by this language. I think the first reason is to improve the signal-to-noise ratio. Kotlin allows to write shorter code, more expressive code compared to Java. And I think that's really important to use a great language to describe our ideas, basically, our algorithm. So I tend to think that's a pretty important point. The second point is safety, and I will use a null safety example. That's an easy one, but that's really important. In Java, the null is a $1 billion mistake. I guess it's much more in reality, but let's say the $1 billion mistake. And it's because null safety is not explicitly managed in its type system. Okay? It's implicit like in dynamic languages. And that creates a lot of issues, and that's surprising because Java is a statically typed language, but Kotlin is in fact a more strongly typed language because Kotlin deals with null safety natively in its type system, and it turns this $1 billion mistake to a useful feature that allows to deal with the absence of value without any runtime costs and without cluttering your code base with wrapper like optional, which has also other limitations. So I think that's a very good example of how you can turn a very big problem that costs a lot in terms of money and quality into a pretty useful feature. Discoverability is also important. I mean, Kotlin allows via DSLs to write some kind of declarative code. So it's code, you have autocomplete, but it's declarative, it looks like a document. And the interesting point is that as soon as you are in the context of this DSL, it provides you a context where you can discover some various configuration capabilities. And we are going to see that later in this talk about how that could apply to Spring Boot, replacing the conventions that you have to know, that you have to understand, that sometimes you forget, by something which is more explicit and more discoverable. That means you don't have to read all the documentation. You can discover the API and the capabilities and the updates directly in your IDE. Another point is the pleasure. I guess we mostly developed in our work time, but I think it's really important to have pleasure when we develop. And we spend quite a lot of time in that activity, so I honestly think we can have much more pleasure developing with Kotlin than with Java. And the last point is Android. I mean, for a long time, Java was and will remain super strong, but there was the server side and the Android side, and both were using Java. And now the Android ecosystem is clearly switching to a Kotlin-first approach. I don't expect, in short term at least, the server side switching to a Kotlin-first approach for a Java-based ecosystem, but I think Kotlin will be increasingly important because there is more and more Kotlin developers. Some companies want to share the knowledge between the Android side and the server side. And since Kotlin has a very great JVM interoperability story, I think this kind of move will increase. So Spring loves Kotlin, and we are going to see how much. So we love so much Kotlin that we have translated all the Spring Framework reference documentation from Java to Kotlin, and I can be sure that it's a lot of work. So now you have in the reference documentation of Spring Framework 5.2, you have a tab where you can switch, and that's a global switch and persistent switch between Java and Kotlin. It's pretty interesting because that allows you to learn Kotlin first. If you know very well Java, you know very well Spring, you switch to the Kotlin tab, and you see how what you know translates to Kotlin with the context that you already know. Also, it's not a crappy automated translation. It's carefully done, and it provides you all the best idioms for Spring plus Kotlin. I mean, if a DSL or Kotlin extensions are available for a specific feature exposed in Java originally, it is provided in the Kotlin documentation. So through this reference documentation effort, we are documenting every extensions and every DSL that we provide in Spring. So for this year, for Spring Boot 2.2, which is about to be released, the effort was focused on Spring Framework. That was so huge, so that's a good first step. Next year, and that's estimate, not too much promise, but I wanted to share with you where we are today and where we want to go to give you more visibility. Okay, so not strong expectations, but I think that's our target. So our target is to expand this Kotlin reference documentation to Spring Boot, all the Spring Boot documentation, all the Spring security documentation, and we are going to see some things about Spring security just after. And Spring Data is a kind of different beast because it provides 17 projects. So we are not sure at all to be able to handle everything. So we are going to try to work on that. My hope is that we could translate common documentation, Spring Data GPA and Spring Data to DBC at least. But it remains to be seen with the data team. But we will try to provide a Kotlin first experience on the documentation as well. The other big feature that we provide is Kotlin DSL support. So Gradle is originally provided with a Groovy DSL that I guess you already know. And I think 2 years ago, they announced that they were also providing a Kotlin DSL. So what does this Kotlin DSL provide? I think Gradle is a very powerful tool, a very flexible tool, but it's too flexible. And honestly, with the Groovy DSL, what I mostly do is copy and pasting some example from the internet and then modifying some small things, and yeah, finger crossed for that for working. And what Kotlin DSL provide is something more statically typed, so with more structure. It looks like barely the same. If you have a look to this source code, it's barely the same than Groovy, but the developing experience, the autocomplete, is it's much better. Obviously, it's not just about changing the language, because Groovy can be statically typed as well. It's how Gradle team evolved their Groovy DSL to something which is suitable for Kotlin as well. And that was a pretty big effort, and still ongoing effort. I'm not here to sell anything, so there is some issues currently, especially in terms of performance. When you are developing and typing with Gradle Kotlin DSL, it could be slow in terms of autocomplete. JetBrains and Gradle team are working on that. For example, we expect for the next 1.3.60 version of Kotlin to significantly increase the autocomplete. I mean, significantly more than twice a shorter autocomplete time, something like that, I think, when I discuss with the Gradle guys. So it's getting better and better. I think, Kotlin team and Gradle team are aware of this pending drawback, and it will get better and better. But I really think it brings some added value. And if you are starting a Spring project in Kotlin, it's pretty nice to not having to learn a new language to write your build file. That reduces the knowledge you need to know to deal with your project. But there is more DSL, and I'm pretty careful in adding DSL, because when you start working with your Kotlin, you can say, okay, extensions and DSL everywhere, and I guess that's not super sustainable. So we are adding DSL where that makes sense. Obviously, we may be wrong, but we do our best to really focus on DSLs that really bring added value. So a new DSL that we provide is the MockMvc DSL. So MockMvc is a pretty DSL-ish Java API that is used for testing web application. But its big drawback is that it is heavily based on static imports, and it makes it not discoverable. And everything I use it, I need to remember what kind of static imports I need to have. And that's quite a strong issue with this API. So what we have done, and this is originally a community contribution by Clean Checkets and Jean-Baptiste Nizet. We provide this request extension. So in my slides, when you see this kind of text highlighted in yellow, it's because it's a Kotlin extension. So every Kotlin extension used in my presentation are highlighted in yellow, and if you are not aware of that, you need to import extensions to be able to use them. They are not usable magically, but your IDE really helps you to provide autocomplete, and it works pretty well. So we have added some, to give access to this MockMvc DSL, we have added a request extension on top of the MockMvc type, and it gives you access to this DSL, which is pretty close to the Java API, but with Kotlin properties, more idiomatic API. And as soon as you have imported the extension, so the extension point, you don't need any static imports. Everything is available in the class path, and you have autocomplete and things like that. And we tried to, we had a pretty long time to mature this DSL, because originally we tried something even more Kotlinish, but then we were super far from the Java API. So we tried to find the right trade-off between the original spirit of the Java API and what we consider is an idiomatic Kotlin API. The other new DSL is the Spring Cloud Contract DSL, and thanks to Tim, he has worked a lot on that, and that was pretty big effort. So we have this kind of DSL which allow, in addition to the Groovy one, to describe your contract. And yeah, I'm pretty happy because it's consistent with the MockMvc DSL, and now Spring Cloud Contract as a first-class support for Kotlin. We have also, I have waited that one quite a lot, and I'm super happy to see it now. So Ria Stein from Spring Security team has worked on an experimental Spring Security DSL, experimental but pretty complete. So the idea is to expose all the configuration capabilities of Spring Security. We have already this kind of Java DSL, which was created, I think, before Lambda were available. So we had to do some improvements to make it possible, but we have this Spring Security Kotlin DSL project in the Spring Project Experimental Organization. The idea is to, so it's available since, I think today, it's announced today at Spring One platform. And the idea is to take the time to mature it in a dedicated repository, and if the incubation is successful, to integrate it directly in Spring Security next year. So this is an experimental project, but directly handled by the Spring Security team with the goal to support it in production-ready style next year. And we have another DSL that you may already know partially. It's the Spring MVC DSL and Functional API. So with Spring Framework 5, we introduced WebFlux, and WebFlux is available in two fashions. An annotation-based programming model, which is exactly the same than Spring MVC, at controller, at REST controller, at request mapping, okay? And a functional one with a router API, and we provided from the beginning a router DSL for that. What Spring Framework 5.2 introduced is providing the same capabilities for Spring MVC, because it's totally relevant to want to leverage this kind of Kotlin DSL, more functional approach, but I don't care about reactive. I want just to use my Tomcat and Spring MVC stack, and that's perfectly fine, and use GPA and all my stuff. So we are introducing that. So we have this kind of handler API, so you will write handlers, which are functions that take a server request as input parameter and return a server response. If we see the implementation, you can see that here I'm generating a server response with this API server response.OK.body with any kind of parameter. It could be a string, it could be an object, and then it will be by default serialized with Jackson in JSON. It's exactly the same capabilities you have in the annotation world, but with a more functional approach. So this is just the ending part. Now, if we add a router, so we have the very same DSL. We try to make things consistent. So this is exactly the same DSL that you may have seen on WebFlux side, but here on top of Spring MVC. You define request predicates. So here I'm defining a route for get request methods with the /hello path, but you can add any kind of predicates based on your headers. You can even create your own predicates in a composable way. You can use nested routes. You can use everything. Here we are using callable reference to say, okay, when this route match calls this handler, okay? And if you want to expose this router to Spring Boot, this is exactly the same story done with WebFlux. You are just exposing the router function instance returned by the router DSL as a bin. You can do that in your configuration, or you can directly do that in an add component bin if you want. If we use a more realistic handler, so you will create dedicated handlers. So in Kotlin, we favor a constructor-based injection. So here, I'm providing a person repository that will be automatically injected because Spring automatically auto-wired classes with a single constructor, so I don't have to add explicitly at auto-wired. I use add component because that's not really a controller because I have only the only part, so I'm just using the generic add component annotation. And for the router, I will basically inject my person handler in my bin function, okay? And I can use more complex request predicates. Here, I'm using accept on application JSON, and then I'm using nested predicates. So the predicates inside the accept application JSON will use this common request predicates in addition to their specific ones. And I'm using as well callable reference to the handler, okay? And it's even more than just some kind of syntactic sugar when you are using another way to express the same thing. You can also create routes dynamically, because with annotation, everything is static. But sometimes when you are developing some CMS, e-commerce solution that your customers is creating something in the back office and you need to create routes based on that, you need something more dynamic. So this is a whole topic because you can create route dynamically just at startup or maybe have some caching, etc. So I don't have the time to cover everything. But the interesting thing is that in DSLs, you are in code and you can use any kind of if, for statements to make things more dynamics. And I think that creates and provides some new capabilities where on the annotation world, everything is kind of static. So another status update about the DSL this time. So the Beans DSL and the WebFlux router DSL are still available, obviously. Spring Boot 2.2 introduced WebFlux Coroutine router DSL. We are going to see that after. The WebMVC router DSL I have just shown you, and the MockMvc DSL. The Spring Security DSL is in, I have used the orange color because it is experimental. It seems pretty great, so I think it's still in snapshot, but when you will have the first milestone, don't hesitate to try it. That's a pretty nice effort. And our goal, like I said, is to incubate it this year, and next year provide it directly in Spring Security. And the nice thing is that, remember, in the reference documentation, I said that we will try to provide Spring Security documentation with Kotlin too. And that means that the Spring Security reference documentation will just use the Spring Security Kotlin DSL to show the example, and everything will be smooth. Okay, now a big part, coroutines. So there is Roman in the room, so I will try to not do too much mistake, but yeah, that will be interesting. Coroutines are lightweight threads. You can create hundreds of thousands of them, so much scalable than a regular thread. The foundation of coroutines are in Kotlin language, but the part on the Kotlin language is pretty small. The big part of coroutines is on the library side. And I think that's a characteristic that is pretty different from other languages. That means that in Kotlin, coroutines are pretty flexible, have great interoperability with other asynchronous abstraction, like the reactive one, like completable future. And there is not that much which is hard-coded, basically, in the language. And it makes coroutines pretty flexible and interoperable with other parts. Also, I have usually heard people disagree on coroutines because they speak of different things. So coroutines, there is an aspect on the language side, there is an aspect on the library side, and maybe somebody say, no, coroutines are too limited because it's only speaking about maybe suspending function, while the other person will talk about all the other stuff that we are going to see. So when you say coroutines, maybe be sure to define what you mean. Coroutines allow to consume Spring Reactive Stack in a more imperative way. Currently, you have Spring MVC with imperative code that you all know. You have Spring WebFlux with this reactive API that we provide by default with Mono and Flux, and Mono and Flux are great. They provide a functional way of describing things. But I think coroutines provide, to my taste, a better trade-off between imperative and functional API, and I will explain why just after. So by default, operations are sequential, okay, like in imperative code. Concurrency is obviously possible. It's one of the main features, but it's explicit. And that's maybe one point where a reactive API and coroutines differ, even if the underlying foundation could be similar. The way you express them is different. And the fact that concurrency is explicit allows to avoid shooting you in the foot too much and make it possible to use an imperative model by default. I think there is 3 main blocks you need to know, and there is more in the coroutines like the channel APIs, but I don't want to cover that because I think there is really 3 main blocks you need to know. The first one is suspending function. So the second one is structure concurrency, and the third one is the flow API that has been introduced recently. And when I say flow, I'm not talking about java.util.concurrent.flow, which is a kind of strange container type in the JDK to contain the publisher and reactive stream interfaces provided with Java 9. I'm talking about kotlinx.coroutines.flow.flow. Okay, so I will refer to that type as flow, but I'm talking about coroutine flow. So suspending function. So to write a suspending function, you will add this suspend keyword to a regular function, and that will make it possible to call inside this function other suspending functions. So blocking is bad in reactive API world, but suspending is perfectly fine in a coroutine world. And here, I'm calling delay that will just suspend the current coroutine during 1 second, and that's perfectly fine. My code is sequential by default, and it will just suspend for 1 second. Note suspending functions color your API, and that's not an issue. I mean, that's a characteristic. There is an interesting blog post about that, quite opinionated, but still interesting, about Bob Nystrom, which is called "What color is your function?" What it means is that coroutines allow to go more imperative, but you still have 2 kinds of function. You have suspending function and you have regular function. Suspending function can call regular function, but regular function can't call directly a suspending function except with a few ones that are provided based on suspending lambdas. So, I mean, it's not necessarily bad. You identify the function that requires some latency and things like that, but that's a characteristic you have to keep in mind, and that makes you have 2 kinds of function, 2 colors of function. The second point is structure concurrency. The example that that was taken by Roman in its blog post, it's the very same. You are loading concurrently 2 images, okay, with some operation that implies some latency, and let's say there is an issue, one of the image don't load correctly, and it throws an exception, okay? We need to define a behavior to know if the 2 asynchronous loading of image should be cancelled. So when one is in error, the other one should be cancelled, and we need to define some kind of scope for that. And that's what the coroutine scope block does. I think conceptually it's not too far from transactions when you can to define some scope as well. And here we define some asynchronous scope to define the behavior in case where exceptions are thrown, for example. And that's, I think that without that building blocks, coroutines will be too limited and won't be a real way of doing reactive things. Here, I think that brings a lot of value. The third point is that coroutines 1.3 introduce in a non-experimental way a new reactive type, flow. So flow is really interesting. Flow is interoperable with reactive streams and support back pressure. Okay, so that means that even if we are in coroutines world with some lightweight threads, we have a way to deal with back pressure, which is one of the main points of our reactive stack. Flow is the equivalent of Flux in coroutine world. So basically, when you translate your reactive API to coroutines, a function that was returning mono of something will be a suspending function that returns something without any wrapper. Okay, and a function that was returning Flux is returning flow, and they share basically the same semantics. And it is interesting to have a deeper look to flow design. So flow is an interface with a suspending collect function with a flow collector parameter, and this flow collector parameter contain a suspending emit function that allow to emit a value. And that's all. I mean, there is other technical function, but basically this is the design. And there is a big difference compared to Eric's Java or Reactor design, where we are in Java and we have to provide all the operators directly here. With Flow, which is pretty interesting and clever, is that every operator, even those who are provided by default with the coroutines library, are extensions. Okay? So if you provide your own operator that you create, it will have the same status than built-in operators. And another difference, and again, I don't want to lie, there is some very complex operator in Flow implementation, okay? Filter, basically, operators that imply concurrency are more complex. Those who are sequential, a lot of them are pretty simple like that. So this is the real filter implementation in Flow library, okay? Have a look to the reactive API implementation and come back to me, you will cry, really. It's much more complex, and except Stefan Maldini and David Kernok, I don't know that much people who can write this kind of stuff. And I mean, it's expected. We are leveraging a low-level capabilities that adds this complexity, and at library level, we are just writing some code that is easier to maintain. And I really like this spirit of being able to leverage some foundation that natively deal with asynchronicity. And on the library side, or maybe in your side, because you may have to write custom operators, everything is doable by a normal human. Okay. So if you want to create a flow, and here we are going to see interesting things, it's that flow is a kind of trade-off between imperative and functional API. So here it's pretty imperative. When we create a flow, I want to emit 3 values. I will just use a for loop and emit those, and delay and emit are both suspending function. But yeah, by default sequential, I just want to emit 3 values every 100 milliseconds, and I just write that, and that's fine. But when you consume a flow, you will have the same kind of operator that you have in reactive APIs. You have this kind of filter, map, zip operator that are pretty nice to define your pipeline. And you see they are highlighted in yellow. So these are extensions, but the IDE does a pretty good job to provide them. We are reusing the very simple filter operator that we defined previously. A very interesting characteristic, and that's where Flow is also interesting, is that the map operator take a suspending lambda parameter. What that means? That means that what you put in the map implementation can call other suspending functions. So I don't have, like in reactive API, call flat map to flatten a mono or a single and that adds some unneeded noise. Honestly, it's just some noise. Here, I will just call any kind of remote operation in my map operator, it's a suspending function. Map deals with suspending lambdas, it's fine. And again, it's much better signal to noise ratio in your code. And yeah, here we trigger processing via collect. You can also transform that to a list, for example, all this kind of stuff. So we have talked about what flow is. So what about Spring support for coroutines? How far do we go? Coroutines are a new way to consume our reactive stack in Kotlin, like I said previously. And we provide official coroutine support for Spring WebFlux, Spring Data, Spring Vault, and Spring RSocket. And basically, the philosophy of what we have is that we provide coroutine API where we provide reactive API. That's really a way to consume our reactive stack. And so everywhere, we will see the detail, but the spirit is everywhere we provide reactive API, we provide coroutine extensions to leverage the very same infrastructure. The idea is that we take advantage of all the Spring reactive stack that we are currently building, including the reactive SQL effort with Spring Data R2DBC, including with Spring WebFlux, Reactornity, etc. And we are using the same semantics of back pressure and the same scalability advantage. But when you consume that, I think the programming model is easier for you to use. For Spring Data, we have this support on Spring Data Redis, MongoDB, Cassandra, and R2DBC, which is reactive SQL. Feel free to have a look to the R2DBC talks during Spring One platform. And when I start working on that, and thanks to Konrad Kawinski, who has created the initial coroutine support, and it was super helpful to have this really early experimental exploration. There is a big difference between Konrad's work and mine, is that it took the design to introduce coroutine types, so you had coroutines web client, coroutines everywhere. And I started that way, and at some point I was creating coroutine something everywhere, so I said, okay, it's not maintainable, it's not sustainable, we have to stop this madness. So I changed my strategy, rework everything, and just introduce, so we leverage reactive type, so you want to develop with Spring and coroutines, just use reactive type, and you will have coroutine extensions on each of this type for any kind of methods that return flux or mono. And we also provide seamless support for the annotation programming model. So if you have this WebFlux suspending handler method, you can now add a suspend keyword to your handler method in your controller. And that's it. We also support flow return types. Notice that for flow, we don't have to necessarily to put the suspend keyword because the asynchronicity is inside flow. You don't have to use suspend function that return flow, just flow is enough. So we have this support. Obviously, instead of delay, you will call some Spring Data Coroutines API, for example. We have suspending view rendering. Here, notice that I'm using the extensions on the model that allow me to use this bracket notation to access to my model. And we provide, like I said previously, extensions for Coroutines API on top of reactive types. So, for example, on web client, we have this web client API that you may have used on reactive side. Here we are using the very same API, but we are calling body to flow instead of body to flux. And it's available as an extension. And it will provide you access to flow where you are calling any kind of flow operator, and that's fine. And the interoperability with reactive stream is very good. So it's really flow and flux share, I mean, they are implemented super differently. Flux implements reactive streams publisher. It has to follow all the kind of rules that reactive streams check in its documentation and design. Where flow, you have seen this, we have just a single suspending collect function, but suspending back pressure is managed by just suspending the function, and then inside Flow implementation, it won't request more data. So effectively, back pressure is managed. Interoperability with reactive streams world is great. So you can just use this kind of API. For the WebFlux router side, so I had to differentiate the builder. So I'm using this co-router, okay, for coroutines router. And here, you will provide your handlers implementation. But instead of what we have seen on Spring MVC side, we are adding this suspend keyword. So in Spring WebFlux, the API that a handler needs to use is a function that takes a server request and return a mono of server response. Here, we have a suspending function that takes a server request and return a server response without the use of a mono wrapper. Okay? And we have extensions like this body value and await and many others that provide you suspending extensions. So basically, Coroutines API. We have also coroutine support for RSocket. So RSocket is a new way to propagate the back pressure across the network. I think this is one of the most interesting things. Because, yeah, back pressure is interesting inside the JVM, but when you can basically translate these semantics between, for example, an Android smartphone and a Spring Boot server, having everything working smoothly, and there is very, very big companies that are using that for years in production. I think that's pretty interesting. Even more when you are able to consume that with Coroutines API. So RSocket, so there is a dedicated talk currently about RSocket, so feel free to watch the video. Basically, we support it with our @message mapping programming model. Okay, it's a kind of reactive messaging. And we support suspending function and flow return types at message mapping level. And we provide coroutine extensions on top of RSocket requester, which is our functional API to request a remote RSocket endpoint. But there is more. People have been asking about how do I use my SQL database with reactive API. Our answer for that is to use R2DBC, which is basically a reactive SQL effort that we are working on. Spring Data R2DBC is not yet 1.0 GA, okay, so it's still work in progress, but we already provide support for it with extensions on top of this database client. Database client is the Spring Data R2DBC functional API. It's a kind of similar to web clients, but applied to requesting a database with this kind of fluent API. And we provide a suspending function to be able to use it in this coroutines world. We support as well reactive transactions. Okay, so we have this transactional operator, which is basically the functional equivalent of @transactional that you may know if you are using Spring Data, GPA, or things like that. Okay, so think about transactional operator as a functional way to express the same things. You define a transactional scope. Okay, and we provide extensions on top of a transactional operator that by default take a mono or a flux parameter. And here we just provide a suspending lambda parameter that allow you to define the scope of your transactions. And it's regular transactional stuff. If you have an issue inside, you have something that is rolled back. And we have also a transactional operator for flow. So if you are using flow, you can use a transactional operator that defines the boundaries of the transaction in your functional operator. I know that's a lot of stuff to hear today, but you will have the time to check after the talk. But yeah, I wanted to say that we have a real coroutines transactional story on the functional side. So I won't have a look to every Spring Data project because the principle is similar, but what you need to know is that we provide full support for coroutine on the functional API side, not yet for the @repository programming model. So here, I'm providing a flow, await one and await, find, replace, and await. By convention, we are using await prefix or an await suffix to identify suspending extensions. Okay, and we are using something with flow in the name for the flow extensions. And these are available on the Reactive Free and Mongo Operations API. So, how much are we serious about coroutines? We consider that coroutines are now the default way to go reactive in Kotlin. I mean, it's perfectly fine if you prefer the functional style. It's absolutely not deprecated. It's perfectly fine. But if you are in Java, you use the reactive style because this is the only one available. Okay? If you are in Kotlin, feel free to, it's different style of programming, so feel free to use the one you prefer. But since people ask about opinion, we consider that coroutines are now the default way to go reactive in Kotlin, and that translates in two things. Coroutines dependency are automatically added by default on start.spring.io, where when you are using a reactive dependency like WebFlux with the Kotlin language. And again, you can totally continue to use reactive API, but that's the default. And all the WebFlux and RSocket Kotlin code samples are now provided with Coroutines API. Okay? So, in terms of status, we had a lot of work, so we were not able to finish everything for Spring Boot 2.2, but we are pretty far, I think. So what we have is Spring WebFlux functional APIs support for coroutines, web client extensions, WebFlux at request mapping at controller support, RSocket at messaging support, Spring Data reactive functional APIs, functional transactions. What we don't have yet, but we will have next year, likely, is Spring MVC at request mapping support, because I don't know if you are aware of that, but Spring MVC support reactive types via our reactive adapter registry. It's less powerful than Spring WebFlux, especially for the types like Flux or Flow, but they are supported. And so next year, Spring MVC will support suspending function. The use case, the more typical use case is you want to use web clients inside Spring MVC, and you want to take advantage of the nice Coroutines API to get all your code more imperative. This is not possible yet, but that will be possible next year. For now, just use WebFlux, and yeah. Spring Data repositories, so you know we have this pattern in Spring Data where we generate the implementation based on the name, file by name, and last something. This is not supported yet for coroutines. This is supported for reactive. We have this reactive CRUD repository that you can extend and provide your own variation. It's not supported yet. As well, add transactional is not supported. But you are not blocked because all the functional variants are available. So we provide all the features. It's just that for some annotation-based programming model, we had not the time to finish. So it's not yet available, but should be next year. I have a sample project, Spring Boot Coroutines demo, that I will continue to evolve and enrich, so feel free to have a look. There is also all the reference documentation, which now documents how coroutines work by default in the WebFlux section, so feel free to have a look and switch to the Kotlin tab. And now we are going to talk about Spring Boot. So, there is one thing that really puzzled me when I was creating Spring Boot application in Kotlin, and I discussed about that with the Spring Boot team for so many times. It's that basically add configuration properties support is really designed originally for Java, which is not super fond of immutable data structure. And in Kotlin, basically, immutable classes are the default. In Java, that's not the case. And everything was using setters and getters and things like that. So until now, we had to use late init var fits, properties like that. And yeah, that made me sad, really sad. So what we have now is the support for immutable configuration properties, which is the equivalent of configuration properties and constructor binding. To answer to maybe one of your questions, why don't you just support add configuration properties and data classes? It's because we have to differentiate that because configuration properties can also be a bin, even if I personally regret it. So we had to have this kind of add constructor binding trigger to know that it's an immutable data structure that need to be initialized differently. It may be possible that in the future we may be clever enough to say, okay, it's a Kotlin data class, then add configuration properties is immutable for sure, and we don't require this additional thing. But we wanted to, yeah, we prefer to do it gradually. So for now, use add constructor binding or use add immutable configuration properties with your immutable data classes. And maybe later, we will just support that on add configuration properties, and we'll have enough information to infer that. Okay, but the great news is that we can now finally use immutable configuration properties, which is just great. Start.spring.io helps now to share Kotlin project more easily. There is this support where you can add in the URL language equals Kotlin to by default have Kotlin language selected on start.spring.io, but I keep forgetting the exact syntax, parameter name, etc. And yeah, and I'm getting old, so it is not going better. So now we have this share button that allow you to generate an URL to share what you have selected on start.spring.io, and that really helped me to remember that. And it could help you to share a project, maybe configured by default with Kotlin and using Gradle by default, or what you prefer. But that's a pretty useful stuff. Thanks for Damien for working on that. Okay, now we are going to talk about Kofu, the mother of all DSLs. Kofu is the application DSL for Spring Boot. So we have seen all sorts of DSL. We have the beans one, the security, the router one, but everything is kind of by convention on Spring Boot side, and Kofu is about experimenting around what could be a Spring Boot if configuration was defined explicitly with the DSL. So this is the application DSL that could leverage all the others. So this is really explicit configuration for Spring Boot using Kotlin DSLs. Currently, Spring Boot is using, for example, the information that you have Jackson in the class path to enable Jackson support. But what if you don't care? I mean, you may use a dependency that has a transitive dependency on Jackson, and you want to start very fast and consume a very low memory and don't care about Jackson. So why? And I'm sure, like me, you are sometimes lazy and you won't explicitly disable Jackson because you don't need it, because you have not enabled it yourself. Okay? So here, it's really about finding the right trade-off for still having the efficiency that Spring Boot provides, because, yeah, I mean, starting an application with Spring Boot is so fast compared to what we did previously, but with more control, less surprise. It's experimental, okay, and we have moved it in Spring project experimental to make that sure, because some people had too much expectation. So so for now, it's experimental. It leverages existing DSLs. It provides composable configurations. We are going to see that in a minute. And when I was talking about discoverability, that's exactly what I meant. I mean, you have to know Spring Boot conventions. You have to understand all the conditions that could trigger such configuration. And I mean, we had a very great talk by the Spring Boot team about that. But yeah, what if you don't want to know all these conventions and just being explicit? It's like in the real life, sometimes it's easier. So this is not the main point, but that's a side effect. It starts faster and it consumes less memory. What we see with the minimal Spring MVC HTTP endpoint with Spring Boot 2.2 is that we start 40% faster, which is pretty big. Honestly, yeah, that's not the main point, but yeah, it starts faster, it consumes less memory. But to me, that's less important than getting your configuration explicit, having more control, less surprise. Okay, but we get that improvement, take it. Okay, so demo. So we are going to see how I can create a Spring Boot application configured with Kofu. So I'm going to create a new project directly. I could go to start.spring.io in my browser, but here I will directly use the support in IntelliJ IDE. I'm going to create a demo Kofu. I'm going to use Gradle. So like I said, since I choose Gradle, it will automatically generate the project using Gradle Kotlin DSL. I'm using, obviously, Kotlin. I will choose Spring Boot 2.2.0 RC1. And I will just use Spring MVC. Something pretty typical. Okay. So like I said, what is generated is a Spring Boot Kotlin project with Gradle Kotlin DSL. I have my regular Spring Boot application class, and I just started with run application. Now we are going to remove that because this is how to use Spring Boot with auto configuration. We want to use the application DSL. So we just remove that, but we keep what is generated. Then we go to the Spring Foo repository, which is now a spring-projects-experimental, but if you go to Spring Projects, it will be redirected. And I'm going to use the 0.2 release, and I'm just going to add this dependency. This Spring Kofu dependency just contains the DSL that allows to configure Spring Boot in an explicit way. So I am adding this dependency here. And now we should have this application DSL. So let's try. Okay, so we have this application DSL. We are going to select the kind of application we want. So let's start by something that is not a web application. And I'm going to add and a main, and I will just run that, and that's it. So this is the minimal application you can create, okay? Obviously, it does not do something, a lot of things. You can see that it starts really fast. Obviously, it does nothing, but let's try something more ambitious. So we are going to use a servlet application that is using Spring MVC, and we are going to leverage the WebMVC DSL. So again, everything is discoverable, and even if I am not very good in live coding, the autocomplete helped me to do that easily. Then, again, it's easy. Even if I'm doing a talk in front of you, I can just have various capabilities. So the router DSL that we have seen previously is directly integrated here. So we see we are assembling the various parts. I'm going to define this kind of stuff, and then in the implementation, I will just write, okay, hello Spring One platform, and I will run okay, so it continues to start pretty fast, even if now we are Spring MVC. And if I go to localhost, I have my very impressive endpoint. Now, we are going to add, so let's say we have a new class, which is called sample with message property, okay? And I want to return something serialized to JSON. So I'm going to say that. Hello. If I run that, it won't work as expected. if I go to the endpoint, okay. It can't convert it because I have not enabled Jackson. So when I say now you are in control of enabling things, so by default I try to provide default not too stupid. So I am adding the string converter by default, for example, but Jackson, I mean, initializing object mapper is quite heavy, and I don't want to do that by default. So it's your job, okay, but I think that's pretty easy to declare the converter list, and you are in charge of providing the converters, the order, the configuration. So here I am adding the Jackson DSL, and okay, I don't remember how I can enable pretty print with Jackson, and I'm lazy. Oh, okay, indented put, so I can put it like that. And again, you have access to all the configuration capabilities you have for Jackson, and I mean, Spring Boot provides so much configuration capabilities for Jackson, I can't remember it. Now, I don't have to remember it. I can use the documentation directly in my IDE to have more information about that. And now, I should be able to have my Jackson endpoint working here, okay? And it's not because I have this Jackson dependency that Jackson is enabled. It's because I have explicitly enabled it, and there is less surprise. And in terms of code, I like that. So what we can do is also adding some configuration properties. So let's say sample properties with var excuse me, class. So my sample property, and I will enable it in a functional way with this DSL. So I will use configuration properties. I will specify here the class in a Kotlinish way. And things are going pretty well because I'm leveraging Kotlin name parameters to specify my prefix. I'm going to add sample.prop1 equals hello. And then here I will get a reference. So valprop. I get a reference from, I can get any bin like that. Okay, so I'm using, I want to retrieve my bin sample properties, and then using okay, so it works. Notice that you can also directly get in your DSL these configuration properties to use it without having to get a reference on that. And also, when I will have fixed this bug, because it is currently, there is a small issue, it deals with default values. And that's pretty interesting because I think we don't necessarily need to use application properties in this kind of model. You can just define everything as default values and provide some customization if you want with the application properties. But I think the model is a little bit different and we need to explore that. But really the purpose is to leverage all the Kotlin features to provide this kind of slightly different way of configuring things and more statically typed, because I think we will have more thing in terms of code and less thing in terms of YAML or properties. But everything is pretty monolithic here, so I can make it more modular. So I'm going to create a web config. Okay, so it's a configuration, and I will take my web-specific code, put it here. Even if I have some bins, I mean, if I have, okay, let's do multiple things at the same time. If I have a sample handler, okay, and you want to declare it only on your web configuration, it's similar to configuration slices, I would say. Okay, so I will declare my bin. bin sample handler. Obviously, I can use more complex things. I will get a reference here. So here, I'm going to take my handler. We don't care here. And I will enable this web config because everything is explicit, so this configuration won't be taken like that. I can create my common config. Okay, let's also configure the logging. I like autocomplete very much. Enable. Okay, and let's say I want to put that when just a profile is defined. I just put that in a profile block. And here, you know, when I start, I can specify some profiles like that. And okay, so you see how other things could work together. And it's even more interesting. I don't have enough time, but for testing, you are going to define your slices very precisely, and there is no side effect. Okay, unlike the auto-configuration model where everything is by convention and where, for example, a dependency could trigger a feature. Here, you are in control of defining what you do, and there is no side effect. So you define your configuration slices, and for your test, you are just creating a new application block just for your test with just the two things you want to test. And we all continue to complain about slow integration test and things like that. So here is the solution, I think, for that, and tests start very, very fast with that kind of stuff. Okay, I think that's enough for today. So you can go to the Spring Four repository on Spring Projects Experimental Organization. Feel free to make me feedbacks, to give me feedbacks. The current stage is not about I keep getting pull requests about adding features. I want flyaway support. Okay, I understand. The focus really now is to get the core principles right. I mean, there is some additional work required on the configuration properties side and a few other places. And after that, when you will have the right recipe, we could extend to support what Spring Boot support, because basically the goal is to provide a DSL for every configuration capability of Spring Boot, and that's quite a long run. So I will need community contribution on that. But for now, if you want to play with it and provide feedbacks on the core principle of configuration slices, testing, mocking, yeah, and basically feedbacks on existing feature and point, okay, maybe here you missed something, it could be super useful. So my hope is to make Kofu the Spring Boot Kotlin DSL integrated in Spring Boot at some point. Obviously, I send a message every day about that to Spring Boot team, and we collaborate on that, and we discuss, and etc. And yeah, it's still experimental. We are discussing. Spring Boot team is interested by the idea, but we are still discussing it. So feel free to share if you like this approach, because it also depends on what you think. If nobody is interested, it won't happen. If a lot of people are interested, it will happen. So feel free to share your point of view. And that's the goal. It's basically application is the Spring Boot Kotlin DSL. And the last point on my little bit of teasing for my upcoming talk about Gradle native, because the Spring Foo incubator at the beginning was experimenting about multiple topics. So coroutines has graduated into something which is in Spring Framework. Gradle native has incubated from Spring Foo and is now in a dedicated project, an experimental one, which is Spring Gradle native is a Spring Project experimental. And the purpose of that is to move forward on support for Gradle native on Spring Framework application, and not just Spring Kofu style application, but every kind of Spring Boot application, including the annotated based one. So feel free to come to the talk we have after with Andy about that. What I can say to you is that in this project we have a Kotlin sample, so it works with Spring MVC, it works with Spring WebFlux, so you can run both of this stack as native image. Currently, it's experimental, but we are working on that to make it production ready. Coroutine support is broken due to this horrible bug, so feel free to add your +1 to push the great GraalVM team, which is really listening our feedbacks, to fix this annoying issue, because currently it's broken. I would like to thank you, and if you have a few questions for the remaining 5 minutes, I will try to answer them. Thank you.